Hey, I'm Tony the Triangle Teletubby, the New York Teletubby as they call me. Let's learn about some classifying triangles today, alright, fellas?
First vocabulary term is a right triangle. That's a triangle with one angle measuring 90 degrees. So here you can see we have two right triangles. And we know they're right triangles because they each have one angle with this little red box. And what does this little red box mean? It means that the measure of this angle is equal to 90 degrees. Over here, the measure of this angle is equal to 90 degrees. That's what the red box means. So they are considered right triangles because they have one right angle. Acute triangles would be triangles with three acute angles. And those would be angles that are less than 90 degrees. So down here we have three examples of acute triangles. You can see each of the angle measures in each of the triangles measures less than 90 degrees. Therefore, they would be considered acute triangles. An obtuse triangle is a triangle with one obtuse angle, and that would be an angle greater than 90 degrees. So down here we have two obtuse triangles, and in order to be an obtuse triangle, you just need one of the angles to have a measure greater than 90 degrees. So since this angle measures 112 degrees, which is greater than 90 degrees, this would be considered an obtuse triangle. Since this angle measure is 110 degrees, which is greater than 90 degrees, this would be considered an obtuse triangle. Now, an equilateral triangle is a triangle with three congruent sides. Now remember, to show that sides are congruent, we're just looking for these little tick marks. If each side has the same amount of tick marks, each of these sides has one tick mark, that means each of them are congruent to each other. Therefore, this would be an equilateral triangle. Same thing over here. Each side has one tick mark, therefore each side is congruent to each other. We also have the measure of each side to show that each side is congruent to one another. Remember, equa means equal. Lateral refers to the sides, so equilateral means same sides or equal sides. Something else that I want you to notice is that in this triangle, this equilateral triangle, each angle measure is exactly the same, meaning that each angle is also congruent. So we have all sides congruent and all angles congruent. And that'll become more important later on when we talk about the measure of the side opposite a given angle. An isosceles triangle is a triangle with at least two congruent sides. So down here we have two triangles that we would consider isosceles triangles because they have at least two congruent sides. Here, this triangle has two congruent sides. So each of these sides would have the same measure. Same thing over here. Each of these sides has the same measure. They're both 5 centimeters. Therefore, they are congruent to one another. So this would be considered an isosceles triangle. Now, just a side note, people usually assume that an isosceles triangle is just a triangle that has two congruent sides, but it's a triangle that has at least two congruent sides, so it could have three congruent sides. An equilateral triangle is technically an isosceles triangle as well, just something to note. Now, remember when I just talked about equilateral triangles, we said the sides opposite the given angles are going to be important? Well, this is why. If you know that two angles in a triangle are congruent, then we could say that the sides opposite those two angles must also be congruent. So if we know that this angle right here and this angle right here are the same measure, then the sides opposite will also be the same measure. So that's why in this isosceles triangle, the two sides that are congruent, the angles opposite them, they're also congruent. Same thing over here. The two sides that are congruent have the two angles that are opposite them congruent. Now, a scalene triangle is a triangle with no congruent sides. So as long as the measure of each side of the triangle is different, it is considered a scalene triangle. And over here, even though we don't have any side measures, since the number of tick marks on each side is different, we know that each side measure is different in this triangle. Therefore, it's a scalene triangle. No sides are congruent. Now take a look at the angles real quick. When we were talking about equilateral triangles and isosceles triangles, we looked at the angles and what it meant for the sides opposite them. Since none of these angles in the triangle are congruent, that means that none of the sides opposite them are going to be congruent. So we have three different angle measures and three different side lengths for this particular triangle. That's why it's a scalene triangle. The last thing I want to talk about is over here. You see that the sides that are opposite the bigger angles are bigger sides. So here we have a big angle, an obtuse angle, angle A, and the side opposite that is the biggest side of the triangle. The side opposite the smaller angles are going to be the smaller sides.
Hey, put down the pizza, it's example time!
Now, example 1 says classify each triangle as acute, obtuse, or right. Then classify as equilateral, isosceles, or scalene. So let's look at triangle ABC down here. First, we're going to determine, is it acute, obtuse, or right? So is it acute? Is each angle measured less than 90 degrees? Well, angle B actually looks like it's greater than 90 degrees. A triangle with an angle greater than 90 degrees is actually an obtuse triangle. So this would be considered an obtuse triangle. Next, we're going to classify it as equilateral, isosceles, or scalene. So let's look at the tick marks. Here we have 1 tick mark, here we have 3 tick marks, and here we have 2 tick marks. Since each side has a different number of tick marks, that means the measure of each side is different. So there are no congruent sides. Which type of triangle has no congruent sides? That's a scalene triangle. So this would be an obtuse scalene triangle. Part B, we're looking at this triangle. So let's first determine, is it acute, obtuse, or right? So acute, does it have each angle measure less than 90 degrees? 60 degrees, 60 degrees, 60 degrees. They are all less than 90 degrees, so this would be an acute triangle. Next, is it equilateral, isosceles, or scalene? So do all the sides have the same number of tick marks? Here, this would be 1 tick mark, 1 tick mark, 1 tick mark. Yes, each side has the same number of tick marks, meaning that each side measure is equal. Therefore, we have 3 congruent sides, so this would be considered an equilateral triangle. So this is an acute equilateral triangle. Part C, we're doing the same thing. So first, we want to classify each triangle as acute, obtuse, or right. So first, is this triangle acute? Does each angle measure less than 90 degrees? So the measure of this angle is 47 degrees, that's less than 90. The measure of this angle, well, what's this little box mean? That means that the measure of this angle is 90 degrees. So a triangle with an angle measure of 90 degrees is a right triangle. So this is actually a right triangle. Okay, done. Next, we need to classify it as equilateral, isosceles, or scalene. Now, the only problem is we only have 1 side measure. So how are we going to do this? Well, I know that all the angles in a triangle add up to 180 degrees. So if I have 180 degrees and I take away 90, that's 90. And then if I take away 47, that's 43 degrees. So the measure of this angle is 43 degrees. So remember, like we talked about earlier, a smaller angle is going to have a smaller side that's opposite it. A bigger angle is going to have a bigger side that's opposite it. So if this angle is 43 degrees and it's opposite the 12 meters, then this side length would have to be bigger than 12 meters because the angle that's opposite that is 47, which is bigger than this 43. Same thing over here. If this is 90 degrees, then that's clearly bigger than 43 degrees. So this side length has to be bigger than 12 meters. And since each of the angle measures are different, that means each of the side lengths are going to be different. So that would be a scalene triangle. So we have a right scalene triangle.
Hey, I'm not trying, you try it.
Okay, doing the same thing. So first, we have to classify it as acute, obtuse, or right. So is this triangle acute, obtuse, or right? So is it acute? Is the measure of each angle less than 90 degrees? Well, this is 45 degrees. Yep, that's less than 90. This is 45 degrees. Yep, that's less than 90. Oh, this angle has a little box or square in it. What does that mean? That means the measure of this angle is 90 degrees. And any triangle that has one angle that's measure is 90 degrees, that's a right triangle. So this must be a right triangle. Boom, done. Next, we need to classify it as equilateral, isosceles, or scalene. Now here's the problem. We don't have any side measures here. Well, what we do know is the angle measures. And what does that tell us? Well, we have 2 congruent angles here, and then one that's 90 degrees. So the sides that are opposite the 2 congruent angles have to be congruent. That's what we just talked about when we were talking about isosceles triangles, right? So this side, segment AC, has to be congruent to this side, segment BC, because the angles that are opposite are congruent. Now this is 90 degrees, so the side that's opposite that, segment BA, that's clearly going to be bigger than both of these side lengths. So we have 2 congruent side lengths. Which type of triangle is that? That's an isosceles triangle. So we have a right isosceles triangle. Here, we want to first classify it as acute, obtuse, or right. So is it acute? Does each angle measure less than 90 degrees? So this is 25 degrees. This is 130 degrees. Oh, that's way bigger than 90 degrees. So any triangle that has one angle that's bigger than 90 degrees, we know that's an obtuse triangle. So this is going to be an obtuse triangle. Now, is it an equilateral, isosceles, or scalene triangle? Well, clearly we have 2 congruent side lengths. That's what these little tick marks mean. And notice the angles that are opposite those sides are congruent. That's how you know it's going to be an isosceles triangle. Since this angle is clearly bigger than both of those, the side opposite that is going to be bigger than both of these sides. So we have two congruent side lengths. That means it's going to be an isosceles triangle. So we have an obtuse isosceles triangle. Part C, we're doing the same thing. So first we need to figure out, is it going to be an acute, obtuse, or right triangle? So is the measure of each angle less than 90 degrees? So the measure of this angle is 60 degrees. That is less than 90. Measure of this angle is 50 degrees. That's less than 90. Measure of this angle is 70 degrees. That's less than 90. So since all of the angle measures are less than 90, this is going to be an acute triangle. Then we have to figure out, is it going to be an equilateral, isosceles, or scalene triangle? So we don't have any side measures here, but we do have the angle measures. And remember, these sides that are opposite smaller angles are going to be smaller than the sides that are opposite the bigger angles. So since each of these angle measures is different, that means each of the sides that are opposite those angles are also going to be different measures, meaning that none of the sides are congruent. Therefore, this is going to be a scalene triangle. So this is going to be an acute scalene triangle. Now, example 2 says find the measures of the unknown sides. So here we have a triangle. What kind of triangle is it? Well, each angle measure is less than 90 degrees, so it's acute, and each side is congruent to one another. So this would be an acute equilateral triangle. Now, what can we do to find the measures of the unknown sides? Well, each side is unknown. But the cool thing about this is that if we find one side, we know the measures of all the sides because they are all congruent. It's an equilateral triangle. So how can we set up an equation? What do we have to solve for? Well, we have two variables here. We have an x and we have a y. So we could either solve for x or y. But there's only one y here, so I can't really solve for y. But I could set up an equation to solve for x. Each of these side lengths is congruent, therefore their measures must be equal. So to solve for x, which is my first task, I'm going to set each of these side lengths equal to each other. So I can say the measure of AB is equal to the measure of BC, or 2x plus 5 is equal to 5x minus 19. Now I just need to solve for x. So I'm going to subtract 2x from both sides. Those would cancel out over here. This would become 3x. Then I'm going to add 19 to both sides. So this would cancel out and I would get 24 on this side. Lastly, I would divide both sides by 3 and I end up getting x is equal to 8. But I'm not done. I need to find the measures of the unknown sides. So that's all three sides. So let's start with one of the sides. How about segment AB? To find the measure of AB, what I'm going to do is I'm going to take 8 and plug it in for the measure of segment AB for x. So if I take 8, plug it in for x, I end up getting 2 times 8 plus 5. So what's 2 times 8? That's 16. Plus 5 is going to give me 21. Now, here's the deal. The measure of AB is the same as the measure of BC, which is the same as the measure of AC, right? It's an equilateral triangle, so all three sides should have the same measure. Therefore, the measure of AB, the measure of BC, and the measure of AC are all equal to 21. Now, part B, we have this triangle right here. So, what kind of triangle is it? Well, it looks like the measure of all three angles is less than 90 degrees. So, we could say this is an acute triangle. And we have two sides that are congruent to each other. So, this would be an acute isosceles triangle. Now, I need to find the measure of all three sides. So in order to find the measure of all three sides, I need to find x, right? That should be my first step. So in order to find x, I need to set up an equation. Well, just like we did over here, we can set two side lengths equal to each other. Which ones? The ones with the little congruent tick mark. So segment QP and segment PR. Those would be two congruent segments, therefore their measures would be equal to each other. So I can set the measure of segment QP, 4x plus 1, equal to the measure of segment PR, which is 5x minus 0.5. Perfect. Now let's solve for x. So there's two ways I can do this. I can subtract 4x from both sides or subtract 5x. I'm going to subtract 5x from both sides. So they would cancel out over here, and 4x minus 5x gives me negative 1x. I can then subtract 1 from both sides, and negative 0.5 minus 1 is going to be negative 1.5. It makes it more negative. I then get x all by itself by dividing both sides by negative 1. I get x is equal to 1.5. But I am not done. I need to find the measure of each side length. So let's start with segment QP or PQ. I'm going to take 1.5 and plug it in for x in the measure of segment QP, which is 4x plus 1. So if I take 1.5, plug it in here, 4 times 1.5 is going to give me 6, and then 6 plus 1 is going to give me 7. So I get the measure of segment QP is 7. Now, notice segment QP is congruent to segment PR. Therefore, their measures must be equal. So if I know that the measure of segment QP is 7, the measure of segment PR must also be 7. Last but not least, I have to find the measure of QR because it is not congruent to these two, so it's going to be different. So to find the measure of QR, we have to take what the measure of QR is equal to, 9x minus 1, and then we take the x that we found, 1.5, and plug that in for x in the measure of segment QR. And when we plug that in, what's 9 times 1.5? That's going to be 13.5. And then 13.5 minus 1 is going to give us 12.5. And that is the measure of segment QR. Now we have the measure of each side. Therefore, we are done.
New York City, gotta do stuff for yourself. It's a you try.
Okay, doing the same thing here. So first, let's figure out what kind of triangle is this. Is it acute, obtuse, or right? Well, it looks like each angle measure is less than 90 degrees. Therefore, it's an acute triangle. Now, we have to determine, is it equilateral, is it isosceles, or is it a scalene triangle? Well, you can see, based on these two congruent side lengths and these two congruent angles that are opposite those side lengths, we know this must be an isosceles triangle. Okay, cool, so that's going to help us. So, in order to find the measures of the unknown sides, there's only two unknown sides, segment AB and segment BC. So to find the measures of these sides, we just have to find x. And once we find x, we can plug it in and get the measures of each of these sides. How do I set up an equation? Well, since I know this segment is congruent to this segment, that's what the tick marks mean, I know that their measures must be equal to each other. So the measure of segment AB must be equal to the measure of segment BC. So then I'm going to take what the measure of segment AB is equal to, 7x minus 6, and plug it in here for the measure of AB. I'm going to take 4x plus 2, which is what the measure of BC is equal to, and plug it in here. Now all I have to do is solve for x. So let's go ahead and subtract 4x from both sides. Over here, they're going to cancel out, and on this side, we end up getting 3x. I'm then going to add 6 to both sides to try to get x by itself, and then divide both sides by 3, and I get x is equal to 8/3. I'm going to leave my x value as an improper fraction right now because I can't round too early. If I round too early, I will get the wrong answer. So I want to leave my x value as exact as possible. That way my end result is also exact. So I take this 8/3 and I'm going to plug it in for the measure of either of these sides. Which one do we want to find first? Well, let's find the measure of AB. Why not? The measure of AB is going to be 7x minus 6, so I take that 8/3, plug it in for x in the measure of segment AB. I then simplify this. What's 7 times 8/3? Well, how do I multiply that? 7 is the same as 7 over 1, so when you multiply fractions, I just multiply the numerators together and the denominators together. So what's 7 times 8? That's going to be 56, and 1 times 3 gives you 3. Now I need to simplify this. 56/3 minus 6. How do I subtract these two things? Well, in order to subtract, you need a common denominator. So 6 is the same as 6 over 1. So to give that a common denominator to the one over here, I just multiply the numerator and denominator by 3. So I end up getting 18/3, which is the exact same thing as 6. Now I can subtract these two things. What's 56 minus 18? That's going to give you 38. Remember, the denominators stay the same whenever you add or subtract. So 38/3 is going to be the measure of segment AB. And I'm going to leave it like that because it doesn't tell me to round. So I can say the measure of AB is equal to 38/3, or if I want to write that as a mixed number, 12 2/3. Now, you could take that 8/3 and plug it in for x for the measure BC, or you could just realize that this is an isosceles triangle where the measure of AB is equal to the measure of BC. So, since they're the same, you don't have to do anything else. We already found the measure of both of those missing side lengths. Done. Over here, what kind of triangle do we have? Acute, obtuse, or right? Well, each angle measure is less than 90 degrees, so it's an acute triangle. Next, is it equilateral, isosceles, or scalene? Well, each side length is congruent. Well, each side is congruent. Therefore, this must be an equilateral triangle. So that'll help us. Now, in order to find the missing side lengths, it looks like the measure of each side has a z in it, so I need to find z. How do I find z? Well, I need to set up an equation. So just like we did over here, we could set two side lengths equal to each other that we know are congruent. So these two sides are congruent to each other, so I can set their measures equal to each other. 9z is equal to 9z. Oh wait, if I were to solve that, divide both sides by 9, I just get z is equal to z. That doesn't help us at all. So let's try this again. How about I set this side length equal to this side length, right? They are also congruent to each other. So if I set the measure of DE equal to the measure of DF, I can then plug in 9z for the measure of DE, and take 2z plus 18 and plug that in for the measure of df. Now I can solve for z. Okay, cool. So to solve for z, I'm going to subtract 2z from both sides, divide both sides by 7, and I get z is equal to 18 over 7. Again, you don't want to round too early. Leave z like this, an improper fraction, because if you round too early, it'll make your other answers incorrect. So I leave 18/7 as z, and I find my other missing side length. So let's start by finding the measure of dE. So what is the measure of dE? That is 9z. So I take 18 over 7, which I know z is equal to. I plug it in for z over here, and now I simplify. How do I multiply these two together? Well, 9 is the same as 9 over 1, so I multiply the 9 times the 18 and the 1 times the 7. When I do that, I end up getting 162 over 7, which I could leave as my answer. Or I could write that as a mixed number, which is 23 1/7. Again, this is an equilateral triangle, meaning that each side is congruent to each other, meaning that the measures are all equal. So if I found one side, which I did, I found the measures of all the sides, which makes me done. Sweet. Now, word problem says you are standing on the beach and you see your friend Amanda being attacked by a jellyfish. At the same time, your friend Jeff is being attacked by a rabid seal. If your locations are as shown below, who can you get to faster? What type of triangle do the three locations form? Okay, cool. So, step 1 in a word problem. We're not scared. We can do this. Step 2. What is the question asking us? It's asking us, who can you get to faster? Meaning, if you run at the same speed in both directions, which person are you closer to? So, which distance is shorter? That's basically what it's asking. So, we need to find the distance between you and Amanda and the distance between you and Jeff. Meaning, we're going to have to use the distance formula. And in order to use the distance formula, we need to know what these ordered pairs are. So, Amanda is at -1, 8. You are at 1, 2. And Jeff is at 7, 0. So first, let's find the distance between you and Amanda, or what we can call the measure of YA. To find the measure of YA, the distance from you to Amanda, we need the distance formula. Again, you're going to choose one of these points to be x sub 1, y sub 1, and the other one to be x sub 2, y sub 2. It doesn't matter which one is which, but as you can see, I already color coordinated it for you. So we'll say you are at x sub 1, y sub 1, and Amanda is at x sub 2, y sub 2. Now we just plug in each coordinate to their corresponding spot in the distance formula, and now we can simplify. Here, -1 minus 1 is going to make it more negative. That becomes -2. And then 8 minus 2 is 6. Now we square these. -2 squared is 4. 6 squared is 36. What's 4 plus 6? That's 40. Now 40 is not a perfect square, so I can't square root this. But I can simplify it. How do I break this up? Well, remember, to simplify a radical, you have to break it into two radicals that multiply together to make your radical. One of the numbers, has to be a perfect square. So which number is a perfect square that goes into 40? 4 does, right? So I break up rad 40 into rad 4 times rad 10. I do that because 4 is a perfect square, and the square root of 4 we know is 2. Rad 10 we could break up into rad 5 times rad 2, but neither of those are perfect squares. So we're just going to leave rad 10 as rad 10. So the distance from you to Amanda is 2 rad 10 units. Now let's find the distance between you and Jeff. So again, we're using the distance formula, meaning we have to choose one of these ordered pairs to be x sub 1, y sub 1, and the other one to be x sub 2, y sub 2. Doesn't matter which one is which, but again, I already color coordinated it for you, so why not make you x sub 1, y sub 1, and Jeff x sub 2, y sub 2. We then plug in each of these coordinates into their corresponding spot in the distance formula, and we simplify. 7 minus 1 is going to give you 6. 0 minus 2 is -2. 6 squared is 36. -2 squared is 4. We're going to add these together, and we get the square root of 40, which you could stop right here and be like, oh, that's exactly the same. Or you could simplify it just like we did. Remember, rad 40 breaks up into rad 4 times rad 10. We chose 4 because it's a perfect square, and the square root of 4 is 2. That's why it comes out of the radical. Over here, rad 10 we know stays rad 10. So the distance from you to Jeff is also 2 rad 10 units, meaning that you are the same distance from either person, so you could get to them in equal time. You just would choose whoever you like more, I guess. Now the last part of this question says, what type of triangle do the three locations form? Well, if I create my triangle here, you see that the distance from you to Amanda and the distance from you to Jeff is the same distance. The only question is, what is the distance from Amanda to Jeff? Because that could affect what type of triangle this is. We already know that 2 of the sides are congruent, so it's at least an isosceles triangle, but is it an equilateral triangle? So what's the distance between Amanda and Jeff, or what we can call the measure of AJ? Well, again, distance formula. So let's use the distance formula. To use the distance formula, I got to choose one of these points to be x sub 1, y sub 1, and the other one to be x sub 2, y sub 2. Those are the ones I chose. You could have flipped it. If you wanted to, you would have got the same answer. So when I plug in each of these coordinates into their corresponding spot in the distance formula, I can now simplify. 7 minus negative 1 is the same as 7 plus 1, and 7 plus 1 is 8. Over here, 0 minus 8 is negative 8. Now what's 8 squared? That's 64. What's negative 8 squared? That's also 64. And then add those together, I get the square root of 128. Now again, 128 is not a perfect square, so I need to break this up. How do I break it up? Well, I need to think about what perfect square goes into 128. Well, there's actually a lot of different perfect squares that go into 128. But the biggest one that I know, so I don't have to break it up even further, would be 64. 64 goes into it twice, right? 64 plus 64 equals 128. Therefore, 64 times 2 would equal 128. So now, why did I pick 64? It's a perfect square, so the square root of 64 is 8. The square root of 2 stays rad 2. So the distance from Amanda to Jeff is going to be 8 rad 2 units. Now, if we look over here, the distance between Amanda and Jeff is 8 rad 2 units, but the distance from you to Amanda and you to Jeff is 2 rad 10 units. Because we only have 2 congruent sides and 1 obtuse angle, this triangle must be an obtuse isosceles triangle. And you're done.